Hey everyone, I'm just going to follow up with Friday's lesson and finish up the normal distribution today. Just wanted to go over a couple of things again. The empirical rule is something that you went over Friday in that video, and it says if data is normally distributed, then it will have these properties. The graph is maximized at the mean, median, and mode are about equal, and then it has these three percentages. So we're going to talk a little bit about that. If you remember, this symbol is the standard deviation, and standard deviation is how much each data point on average varies from the mean. So standard deviation is how much it varies from the mean. So it tells you about the spread of the data. So if it's normally distributed, then you have the mean in the middle. So the mean is here, which it called it the mu, and then plus one standard deviation would be here to here. And what the empirical rule says is about 68% of the values are within one standard deviation of the mean. So either way, there's 68% from here to here. 68% of the data is from here to here. So overall, from the midpoint to the right, that would be 50% of your data and 50% of your data. So if this is 68, half of 68 is 34. So in each section, that would be 34%. So I'm going to make this a little bit bigger. So 68% is in that middle part. So 34% and 34% would be in those middle parts. Then it says about 95% of the values are within two standard deviations. So if you think about it, from here, two standard deviations to here would be a total of 95. If I divide that by 2, that would be how much is over on each side. So if I took 95 and divided it by 2, then that means 47.5 is from here to here. So 47.5, but I already have 34%, so I would subtract that. And that means 13.5% would be here, and 13.5% would be here. Okay, and then within 3 standard deviations, 99% of the data would be there. So if this is 95, then you would have 4%, or excuse me, if this is a total of 95 right here, so 95% of the data is here, 68% of the data is here, and roughly 99% of the data is 3 standard deviations. So 3 standard deviations holds 99% of the data. So from here to here would be 99% of the data. So in this green section is 99. You have 95 here, so that's 4. So this is approximately 2% in each section. The video said 2.5, but it took in consideration the whole 100%. So either one is pretty close. All right, so the example that was on your worksheet that that you did, and it looks like this. Let me pull it up here. So this worksheet is something I sent to you Friday. Looks like this. It had 3 pages on it. The number of eggs laid per year by a particular breed of chicken is normally distributed with the mean of 225 and the standard deviation of 10. So what happens here is you should visualize that normal bell-shaped curve because it says that it's normally distributed. That's very important. Now you're going to label the mean, and the mean in a normal distributed bell curve is right in the center. So your mean is 225, and it says the standard deviation of 10 eggs. So if I made this, it would be 235, 215. And then if I did one more, it would be 245. And then here it would be 205. So you get the point there. It's going up by tens. Question A says, about what percent of chickens will lay between 215 and 335 eggs per year? So it's asking, part A is asking about this. And what percent? If it's normally distributed, then that's going to be 68%. Because it's within one standard deviation. That range is one standard deviation away. Part B says, in a flock of 400 chickens, about how many would expect to lay more than 245? So if you look at 245, it would be here. Which, if you remember, past that is 2% or 2.5%. So I would take either one there as far as the answer goes. Above 245 would be right here. So that's either 2% or 2.5%. Depending on which one you're looking at. So if I had 400 chickens, I'm going to go ahead and do 2.5% because it would be the whole 100% if I did 2.5. So I do 400 times 2.5. 400 times 2.5%, which is really 400 times 0.025. So if I do that, 400 then I get 10. So in a flock of 400 chickens, about how many would you expect to lay more than 245 eggs per year? Here's the space that represents, and then 245 times 2.5% would be 10. So in a flock of 400 chickens, 10 would be laying more than 245 eggs per year. Okay. The next worksheet says determine whether the data is positively skewed, negatively skewed, or normally distributed. So I want you to cross these out, and we're going to just call this skewed left, skewed right. So a bell curve that's like this is normally distributed. There's two other kinds. The other one is skewed like this. So all the data is pushed towards the right. But this one is called skewed left because of the tail. If you have data that looks like this, that's skewed right because of the tail. So if you look at this data, it wants you to state whether it looks like the first one, second one, or third one. So let's look at this. Miles run track team members. So 3 track team members run between 0 to 4 miles. 4 track members ran between 5 and 9. And you can see the so on and so forth. So what would this be, skewed left, right, or normal? This would actually be normal if you look at this. So you have a 7 in the middle, which is big, which is the biggest. And then on each side of that, they pretty much match up. So that would be a normal distributed curve. Okay. Normally distributed curve. All right. So for your homework, you're going to complete this entire worksheet that I sent Friday. 1 through 2. 1 through 5, and then 1 through 5 again. So I need you to do all those worksheets from Friday, and I will also send you an additional worksheet. Email me if you have questions.